In this video, I'm going to explain what happens to this block, which is attached to a stretched piece of elastic when I let go with my hand. Let's watch the video and see what happens. You can see that it accelerates this way, but let's use this structure here to explain what happens. Let's consider the instant that I let go of the block, and the first step is to identify the forces that are acting at this instant. I think there are two individual forces acting. I'm going to have tension in the elastic, which is acting in the forwards direction, and I'm going to have friction in the opposite direction, which is acting backwards. And I can see that, to begin with at least, the tension is much larger than the friction. Remember that the resultant force will be a single force that would have the same overall effect as the tension and the friction. The resultant force is clearly going to be forwards because the tension is bigger than the friction, which leaves me with a resultant force in the forwards direction. If I'm being accurate, the length of the resultant force arrow should be the length of the tension arrow minus the length of the friction arrow. Now I need to identify what that resultant force causes to happen based on any existing motion, for which I have my little help table here. Perhaps I should have included a fifth row for the scenario where a stationary object has a resultant force acting on it, but that will cause it to accelerate as well, so that's going to cause it to accelerate in the direction of the resultant force, and so it accelerates forwards. To put all of that together, when I first release the wooden block, there is a large tension force forwards, a smaller friction force back, so the resultant force is forwards, and the resultant force forwards causes the block to accelerate forwards. I could now repeat all of that a little time later when the block is now moving forwards. The friction will still be acting backwards and be the same size, and the tension will still be acting forwards, but it will be a bit smaller than before because this elastic will be less stretched than before, so the tension will be smaller. That will mean that there is still a resultant force forwards, but the resultant force forwards will be smaller, and therefore we've still got a scenario where the block is moving forwards and there's a resultant force forwards, which will cause it to accelerate, but the acceleration will be less than it was before. Hopefully you're starting to see how this three-step structure can help you to write really good explanations. If you want a further example of a cupcake case being dropped, then click on the end screen video to watch the next one.